So calculating these areas out, so this surface is going to be 9.61 pi, the two circles. The rectangular surface is 75.64 pi. So the total surface area, when we add that all together, is going to be 298.01. So I'm going to just convert that to decimal since we have decimals here. Okay, so 0.1, in this case, millimeters squared. Okay. For this one here, we want to find the surface area of this shape. We can't really draw a net technically because in this one here, there's going to be this outside strip. There's going to be kind of a top surface like that. There's going to be a bottom surface like that, donut surface. And the inside surface is going to have to be calculated separately. It can't be drawn as a net. So to find these areas, I'm first going to calculate the area of the outside circle and subtract the area of the inside circle. So I'll do that I'm going to do that in red here. Okay, so I want to calculate that surface. I've got 40 squared pi minus 25 squared pi. Okay, so when we work that out, I'm going to end up with 40 squared minus 25 squared is 975 pi. Okay, so that top surface and the bottom surface are going to be 975 pi. Okay, that band on the outside is going to be the circumference of the outer circle, so the width of that is going to be 80 pi. So I double the radius. I multiply it by pi. The height of that is 12. So 80 times 12 gives us 960. So this area in here, I'm going to do it in a different color, do it in green. This area in here is 960 pi. Okay. So the last part is this circle here, the inside of that. Okay, so the inner radius is 25, so the circumference is 50. So double the radius times pi, and that's 12 high, and that band's going to be 12 times 50 is 600 pi. So when we add up all those surfaces, I'm going to have 600 pi, 960 pi, and then I have those two, the top and bottom circular surfaces. Adding that all up together, what I get? I get 975 times 2 plus 960 plus 600. Okay, I'm getting 3510. Okay, so 3,510 pi centimeters squared. Okay, so that works out to be the surface area, counting for all four surfaces. Okay, so this kind of box, it looks like a post box. When I draw the surfaces, I'm going to draw this top surface here, and I'm going to cut it off there. Okay, but technically we could have a bottom surface. Okay, we can have then our side surface like that. Again, I'm going to break that up into two surfaces, the rectangle and the half circle. And I'm going to have kind of my side walls here. And I'm going to have kind of the roof, which would be, I'm just going to highlight that. This is going to be these edges here. Okay. Now these three surfaces, this one, technically could be just wrapped around as one surface, but I'm going to treat them as three separate surfaces. Okay, so then these are all just rectangles. I need to find the bottom rectangle. The side rectangles are 11 by 6, so 66. This rectangle in here is 9 by 6, so 54, 54. And then the circle parts. Since these are two half circles, I'm just going to calculate them as one circle. It has a radius of 4.5, so I'm just going to draw it over here. It's going to be 4.5, so when I calculate this, it's going to be 4.5 squared times pi. So 4.5 squared times pi is going to be 63.62. Okay, so this is 63.62, and this would be millimeters squared. Okay, and that would represent the 2 half circles. Okay, so I'm going to keep track of that. That's going to be these 2 pieces right here and here. So the last piece then is I need to calculate this length and multiply it by the length of 11. So that represents half the circumference of the circle, or 4.5 pi. Okay, so the diameter times pi divided by 2 is radius times pi. So that's going to be 4.5 pi times 11. So 4.5 times 11 gives me 49.5 pi. So I'm just going to multiply the pi in. And I get 155.51 millimeters squared. Okay, so then I'm going to just sum that all up, make sure I keep track of my areas versus my length. I don't want to mix those lengths up. So I'm going to add that to 63.62 plus 66 plus 66 plus 99 plus 54 plus 54. Okay, so I'm going to get a total surface area. Okay, as long as if I've kept my counting good, my total surface area works out to be 558.13 millimeters squared. So this is the last shape here. If I want to calculate the surface area, I basically have a rectangular box plus the cylinder with a little top on it, and I have to make sure that I cut out the circle here. So if I draw the net of this, it looks like this. There's the bottom, sides, front, back. I'm going to put the top over here. And the top has a hole in it here like that. Now, I also have a cylinder which I have to account for. And the cylinder only has a top. But this circle and this circle match. So if I want, what I could do is I can fill in that circle by just putting this on top like that. I can just fill it in. So what I'm going to do is, instead of calculating this circle, I'm just going to assume that that circle covers the top, and I don't worry about this and this. Okay, so I'm just going to actually place it in there like that. Okay, and then shade it a little bit differently, but that's going to be accounted for in this rectangle, and I don't have to account for in this rectangle, in this cylinder, top of the cylinder here. Okay, so there are my parts. I'm going to calculate my areas. 14 times 8, it is 14 times 8 is 112. That's my bottom. Okay, my front is going to be 12 by 14, okay, which is 168. Okay, the back is 168. Okay, the top is going to be 112, okay, because it's going to be same as the bottom. The side is going to be 8 times 12, which is 96. Okay, so I'm going to have 96 square feet here, 96 square feet here. So I've accounted for all the rectangular parts here. The side surface of the cylinder, it's 8 tall, okay, and it's going to be, the diameter is going to be 8. So diameter times pi is my circumference, which gives me that edge. So that's 64 pi. I'm going to leave this in terms of pi. Add up all the rest. So I'm going to add up the rest of those. Okay, so I'm going to end up with 752 square feet, plus, that's going to be this, all this part here, plus this one side surface of 64 pi, and that's going to be square feet. Okay, so there it is.